Hello everyone, my name is Philip Wirtz and I am a junior at Grace College. This is my second video discussing the research project I've been conducting this spring. If you did not get the chance, go back and watch my first video explaining how I collected the data and ranked hitters and pitchers in the NAIA Crossroads League, which is a conference Grace College plays in. In this video, I will use that data to make predictions about the games played in conference this season. To do this, I use ELO ratings, a system widely used in sports analytics that assigns each team a rating and adjusts based on the outcome of each game. Our first step is to take the games that we gathered from 2019 in the Park Factor notebook, which is explained in more detail in the previous video. Then we add a column for the team that each data frame corresponds to, and for notational purposes, we shorten the name of each team. Then, to isolate each game only once, we filter out each team's data frame to show only their wins. We then change a few header names to make the data more understandable. Now we can get into our ELO functions. Our functions have been adapted from the URL that you can find here. Basically, the way this function works is it takes two teams and the winning team takes a certain number of points away from the losing team and adds them to their rating. We added a modification for the margin of victory, as well as a home field advantage. So we give each team a base rating of 1500, and we store these ratings in a dictionary. Then we go ahead and run that function for every game played in 2019. So here's our ratings at the end of the 2019 season. Since those games were played 2 years ago, we regress the ratings back to the mean of 1500 by a third, and we do this twice, once for each year. Now that we've regressed the ratings back to the mean, here are our ratings for the start of the 2021 season. To make any predictions, we have to have a function that will give us a probability of victory. So this is the function that we create to do that. And here's it in use. If we take Grace playing a 1500 rating team at home, Grace has a just over 50% chance of winning. Then we have to go back to the DAXstats website and take any games from 2021 that we don't have updated into our rating system. We do this with the Get 2021 Games notebook that I created, which I won't go into detail in this video. We run the same function over those games and print out our most updated dictionary of ratings. Then we pickle the ratings. Now we're ready to make some predictions. If we don't have the most updated rankings, we can uncomment these lines and run them. We take our ratings and we take the same functions that we used in the previous notebook, and then now we can get into our two models. The first model is an ELO model. And what this model does is it updates after each game played in a series. So in the Crossroads League, each team plays each other team 4 times in a 4-game series. So if the underdog wins game 1 of the series, they're more likely to win game 2, game 3, and then game 4. So this function allows us to input the winner of each game's a 1 or a 2 based on whether the first or the second team won. Then it takes the probability for that team winning and it plays the game with a certain team winning. Then at the end, it takes all the probabilities and it collects them in a dictionary based on the number of games that the first team listed wins. This dictionary is called T1 wins. Then we create a function that loops through all 4 games, assigning it a value of 1 or 2 depending on the winner of the game. This accounts for all possibilities of the 4-game set. Then we return our dictionary of ratings, of probabilities. So here we use this with Grace and Huntington, and you can see that 1 win for Grace is the highest probability, and if we sum all of the probabilities, we get 1. Our next model is a little bit simpler. We take the probability that one team beats another before any of the 4 games are played, and we treat this as a binomial distribution with this probability function, where n equals 4 trials and k represents the number of games won by the first team. We plug those values into the function here, for the number of wins by the first team, and then we print out the same dictionary of probabilities. Again, we demonstrate this with Grace and Huntington. So notice, one win by Grace is also the highest probability, and if we sum them, we get 1 again. For visual purposes, we create a function that will graph these probabilities next to each other. So here you can see this with Team 1 and Team 2 and some arbitrary probabilities. Notice that each model is color-coded, with binomial being blue and ELO being orange. Then we put our ELO simulation, our binomial situation, and our graph function all in one function that we can run to predict each series. Now, since we're comparing the two models, we create a function that will, at the end of each week, take the average difference between the probabilities of each model, and it will print out which model has outperformed the other based on the actual results of the series. Then finally, we have one function that will take each result of an individual series and show us whether the ELO model better predicted it or the binomial model better predicted it. So let's look at a weekend of games. Here we have our ratings, and we take a look at our first matchup, which is Grace versus Huntington. So notice we run our prediction of the series, and we get this graph. So you can see that Grace winning 2 and Huntington winning 2 is slightly the most likely outcome, followed by Grace winning 1, and then Grace winning 3, and so on. We take a look at our actual results and see that Huntington won 3 and Grace won 1. So when we print out the results, we see that our ELO probability was just a little bit lower than our binomial probability. In fact, by 1.63%. We do the same thing for each other series played in the conference that weekend. St. Francis Spring Arbor, Taylor Bethel, Iowa Mount Vernon, and Marion and Goshen. Then we show our predictions and compare them with the results, and then at the end of the week, we show which model has outperformed the other. At the end of the first week, the ELO outperformed the binomial by 1.57%. With 2 weeks left in the season, we take a look at which model has outperformed the other. And notice that the ELO model has slightly outperformed the binomial model by 0.31%. So not a huge difference, but a minor change. So that's all the time I have for you guys. Thank you for watching, and if you have any questions, just leave a comment. Thank you guys.